Well, Google says I'm live, so I must be. The time, it's Mike Levin on Thursday, March 12th, 2020. And I see I have 3 concurrent users here. I am going to let you see my broadcast software at first to understand how I'm sort of settling into this new way of broadcasting. I'm going to pop out my chat. And anyone out there who wants to talk to me, I'm going to try and make sure I keep this chat window visible. And I'll comment on things I do, even down to the point of understanding that I am using Windows 10 specific features when I do layout work like this. And this is the kind of stuff which, even though I'm on Windows 10 and I'm enjoying it, I am letting you know that this is the part that I try and make optional of my entire workflow. The operating system, the host operating system, is mostly a place to just provide a web browser and a terminal window. And so my web browser is already running. I like to show you how I get started with these work sessions. And normally I keep setting up this window for last. However, it's required for the live streaming. So I figured I would get this going initially. And let's see. I can't see how many users are online from here. I actually have to go to here. It dropped down to 1 concurrent user, so I lost a few people. But this is probably going to be a video that goes on for a little while, freed from the higher pressures of trying to make a perfect single take video. I use my natural style and I just sort of forge on, as opposed to those very polished videos. So the first step I do, usually in the morning, is I open my terminal, and this establishes my continuous thought process for the day through the use of journal entries. And I have recently done a reboot, so this time delay here is actually first boot of a Unix system or of a Linux system under Windows. And I just hit my keyboard shortcut for journal, and then I do my macro for start a new journal entry and hello world. This is Mike Levin streaming on Linux. That's a little misleading. Mike Levin on Linux, streaming on YouTube. So I'm sure a lot of people, most people, will be seeing this video after I've actually allowed the built-in PVR features of the streaming stuff to kick in and make this one of my normal YouTube channel videos. I'm dealing with a little bit of system lag here. I'm not on the speediest of systems for streaming, by the way. I'm on a Microsoft Surface Book 2, not one of the Surfaces. It's a Surface Book. So it's a little bit different of a device. It was top of the line about 3 years ago. Now it is slightly old technology. And this weird combination of software that I'm doing to achieve streaming is might be pushing this right to the edge. I have this ODBC software over here, several screens to the right. Usually I put it on screen 5 now. But even flipping between screens is creating pointer freeze. So I want to look at my broadcasting software to see frame drop rate and stuff. Yeah, I was just 1 away from it. I should have gone 1 further. Yeah, there's definitely a little bit of loss going on there, but it's still saying 0.1% loss, so it thinks it's streaming pretty well, so I will trust it and forge on. I'll do the Windows tab way of switching back. I'm not sure if you can see the same lag I'm seeing, but it's definitely there. When last we left off, I had used this extremely small amount of code for what it's doing and showed you how the use of these external libraries, this one that I sort of created in front of you, ML SEO, can allow you to do things here, just calling functions, and how you can use caches on your imported files in conjunction with the files that you've imported as modules in order to store stuff locally without having to even think about databases. So that's what's going on in this crawl function, in this links function that is used by the crawl function, and by this SERP function down here, which hits Google for the search results. And what I'm going to do today, and because of these caching features, it turns out that I don't even need to store stuff locally, because in a 7-day window from when I first ran it, it is going to stay persistent in memory, and only things that are not side effects of functions are going to show. So if it's a side effect, it doesn't show. If it's the primary output of a function being printed to the console, it will show. And that's how we have what we have right now. So it's always nice to do a restart and clear all outputs so that there's no confusion about what orders things ran. I dragged things around to reorder it because in talking through this app, it makes more sense to talk through. Here are the keywords for which I'm going to run SERPs. Here are the sites for which I'm filtering out of the results that I'm looking at to consider for site crawling. So we can run that. We can run that. But catch up with me. This here is the one that has the slight delay. Something in here is... Now, it's of course because I recently restarted my system and the Python virtual machine in the background is just running for the first time. So that accounts for a lot of the initial time delay. So this is a function that will actually do a crawl of the first 5 sites from the SERP results of each of these keywords which it has searched on, or which there is a search in here. So it does the whole thing, but the fact that it spins through them so quickly shows you that the results are cached. Now, if I wanted it to go one more further into the search results, and instead of going 1, 2, 3, 4, 5, I'll let it go 6 into the search results, which will trigger off a whole new crawl for the 6th site in each one, and you will see what things look like when the cache is not handling the returned data. So a new site came up, this onethingwell.org, and it's going to crawl up to 100 pages from that site. So each time it does one of these steps, it's going through the recursive process that many crawlers use to do a breadth first search. One of these numbers will gradually go up and then start to go down, and as it goes down, it's done the crawl, but it never reaches that bottom number of going down because I have it stopping at such a really small number of sites to allow it to visit and crawl in the sake of speed. But you can see how it's running significantly different than the first time through, because on the 1, 2, 3, 4, 5, 6th site, devhub.io, it actually performs a crawl. And we have an error. Let's see what that error is and clean the code up a little. Forcibly closed, connection aborted. An existing connection was forcibly closed. So all we do on that, I think, is throw a try around what essentially is a HTTP action, which is probably inside the crawl function, which is where I want to address that. So that'll be pretty easy to find. It'll be either the link function or the crawl function. The error actually contains it. You read these things often from the bottom up. It tells you where deepest in the library it was called. So you sometimes, okay, so it's connection aborted. We read that one already. This is the deepest place in there. And you start looking up through your errors until you find the file that is under your direct control. See how these are in site packages? That's part of requests API.py. But once you get here, MLSEO, yeah, exactly as I thought. It was. It's this, and if I wanted to, I could actually even copy that. Got to learn Jupyter Labs a little bit better. Control C will probably do it. Go over here, Control F, Control V, enter, and there it jumps us right to the line. It's inside of links, which only makes sense. So you can simply put try. Now the temptation here is to just silently continue, but it won't be able to, because it won't be able to return all the links it finds. Oh, hi Joseph. So you got to actually tell it what to do. It's probably going to return from the function. Here we return a tuple with links objects inside of it, and the links object, a links append. Oh, I'm appending to it, so it's clearly a list, a tuple with a list inside. Okay, I'll have to figure out all of what I'm doing there. But if a single call to this fails, then you should just return with none. Is that a single point of return is how this stuff is normally done. So you try and create a response object to the request object. When it can't, though, you don't have anything to work with. So you want it to just sort of exit out there. Yeah, it's okay to have 2 points of return. It's, in this case, going to get us through the crawl. So I save, I go back here, and as you'll recall, imported libraries. We run this again, and because of this magic little reload comment here, it's back in memory, and we can do this crawl again. And all this is just completely safe to do, because as you see, now the crawl of one thing well is already cached, and it was somewhere through here where it failed, and whichever URL it failed on, it'll silently skip over, and not necessarily. None type, yeah, of course. If you're returning a none type, whatever is listening for the returned value is going to say, hey, I can't do with this thing that you're giving back to me what I'm supposed to. So, of course, that is the place where the links function is being called from the crawl function. So we're going to find right in here links with an open parenthesis. There it is, see? So that too is going, well, we can proactively check for a none value. So if page links, in the next place page links is used, and that would be right here, because see, we set it persistent. But if no page links came back on that crawl, you want to continue with the crawl, but it is, let's see, it's probably going to be this other one. It's inside this loop. You want to, this one, I should check it here because this one could fail, but really it's this one here that is surely the culprit because it's going through a loop And it's easy to handle it if you're going through a loop. You do a try here. Oh, well, new links would be equal to none. So if new links, because you have to have the possibility that there are no new links, returning none will make that return false. And am I doing a return value here? Very interesting. It's all about getting the site, getting the site crawled. I have some people watching. And so this is an example of, well, what's it an example of? This function would return none, and so new links would not be equal to anything. So all the follow-up work of that iteration of the loop is basically skipped. And that should get rid of that next error if I have this correct, although I do have to take into account this crawl. So if this first crawl attempt to find links here fails, that is definitely a bad sign as well, because then you can't continue. You don't have the seed links. So I can say if page links, and we proactively get rid of the possibility that this would fail and stop the program. So if page links, and it goes on, it goes down to here, all links equals set, and page links is just committed here. We make it persist, but if page links doesn't exist, let's find the next place it gets used. Again, the things we'll do to avoid a little bit of typing, but it's really not right. Oh, interesting. You just put it in there, persist, set. So the next thing we're really looking is for unvisited file name. And it's right here, and it starts right after this. So this whole thing here, if restart, if page links, message is outdents all the way to there. See, the temptation is to just return here, but you're trying to avoid multiple return points. Although I did it once in the links thing, and I think I'm going to do it here just to keep things moving along. I'll print some output. And that is the first page that initiates the crawl. So if it doesn't find links there, it can't enter this loop down here. And so the bad thing about this from a convention standpoint is you don't want to have multiple returns. It just makes things harder to debug in the future. You want things to elegantly fail and then continue with the condition not being met until it reaches the same return point everything else takes. However, that's refactoring, and I don't feel like refactoring right now, so I am going to pop right back over here, import that again, and remember, there's no harm in re-importing and re-importing and re-importing libraries. That's one of the things about Python, and one of the things about Python that makes it work so well in a REPL environment, read, eval, print loop. So let's see if it gets through this without the error, those tries and exits from those functions should pretty much ensure that it won't get an error It won't interrupt the crawl, it'll finish. It might skip over some of the sites it was supposed to visit to crawl or something like that, but it's not going to have the errors that it had before. And I know that the title of this video is on how I'm going to do a non-database database using the shelve standard library of Python, and using the shelve package in the standard library of Python. So I happen to be looking at it on 3.8. It's really 3.7 that's in Jupyter Lab, but that's neither here nor there. The APIs don't change that dramatically from version to version. So as soon as this crawl is finished, we'll have some data that we'll be using in a more persistent database even than this cache one. I could pump up the amount of time that this cache is supposed to leave the data around, which is at this 1 week level, 7 days. However, this is just all a safety net, the use of the cashier, so that I'm kind during development work, so that as I'm re-executing this SERP function over and over, it's not really hitting Google again over and over. So there, it's done the crawl, and as you see, as it got to this new site, rocketreach.co, it initiated a new crawl. Now that crawl data is cached, as well as it is for devhub.io. So that means if I were to run this again, watch how fast it gets through that, right? It doesn't re-perform the crawl. And I showed you here that the crawl data is sitting there now on the last loop. There's actually multiple crawl datas, which is a little bit inaccessible because it's only in the cache, except on the last iteration through the loop, because of the way these Python variables work with the closure, leakage, I don't even know what you want to call it. But because all this is in main and I'm not using functions, why would you use a function with this much code? Functions are for other places that you're importing code from. Now, as you're working on one of these notebooks in Jupyter Lab or Jupyter Notebook, the truth is you will create ad hoc functions, and you'll throw them in the right place so that they become resident in memory by the time you need them. However, the goal is to gradually copy and paste all your supporting work into something like this, which works as a module import. So you focus on program flow. Look how easy this whole program flow is, right? It's almost impossible to not know what you're doing if you can just read a little bit of Python code. The hardest part here is understanding things about zero-based indexes and the shapes of objects being returned. But we're going to try and use named tuples, named tuples, to even alleviate that. In fact, that'll be coming up soon enough. I feel like I want to throw the import here, but let me focus on the real purpose of the video. I'm using these videos to sort of compel me forward so that I get over these kind of hurdles that I have, that everyone has in these works, like what's the next step, why? And because of the principles of commitment and consistency by Robert Cialdini, whenever you're stating what you're intending to do in public, you tend more to stick to your plans because you put yourself out there and you want to have the self-consistency. So let's state the issue. Again, we've got this triality. Think and see, and I don't have it launched yet, but visualize. And I had a little bit of issue yesterday on my streaming when I tried to do the drawing, but I don't think I'll have the issue now, although my audio is probably terrible as I move things around. I will be able to draw. So we have dictionary objects. as part of, actually it's a set, and it's a set of named tuples. You know you have a named tuple. You know you have a set because of the curly bracket. You know you have a named tuple because the thing outside a parenthesis, it looks almost as if a function is in there, is the name of a named tuple that I created over here in this other file. And it has named arguments on site, rel, URL, and then this is another named tuple. It's sort of a nested named tuple used as a key, but because all this stuff is immutable, even nested named tuples, they can be used as members of a set, and they can probably even be used as key values in key value pairs. However, as a set type crawl, this whole entire thing can also be used as the value in key value pairs of a dictionary. So we're going through a loop here, and we're losing crawl equals on each iteration of the loop. It's not going anywhere. Our lovely cashier package is making sure it's getting cache, so if you re-execute it, it gets it from out of the cache. But it's very difficult to access that data except by exactly rerunning the function as you did and relying on the cashier package to repopulate your data. But you're sitting here and you still don't really feel like you have access to it because you stepped through the loop. You don't have anything sitting persistent in memory that has the super shape that's implied by refetching this crawl data, refetching this crawl data. So you have a key. The key is the keyword search. Each keyword search resulted in SERP data, and for each item in the SERP data, we performed a crawl. So it's really for each item in the SERP data, that is a key to what comes out. So the question is, let's see, for each item in SERP. So that's a URL. For this given URL, here's the crawl. That was SERP. Right? This is the crawl. Wow, there's really a lot of data. This achieves an awful lot of the audio. No audio. The audio is... Let's take a look at that audio. Okay, the level drops to 0. So my filters are good. I need to not touch wires and stuff around me. I can see just my voice coming through, and that should be pretty good audio. Unless there's a whine or a hiss in the background. Bear with me. Sorry, these are the early days of my streaming, so you're going to see me doing my little tweaks just to understand what the heck is going on. This is my audio, and I can hear it. Okay, I think I made it a bit better. Okay, so the question is, what should our key value pairs be? We're about to do database-like stuff. but it's more like NoSQL. Where it's just key value pairs, but what keys and what values. My principles here are usually avoid nested objects. Hard to know what you've got. And navigate. Keep it as flat as possible and use named tuples as keys when it when it solves your problems, really. Sometimes it's necessary. Sometimes you don't know it's necessary. Sometimes your coding style for years is worse than it could be because you don't know that any immutable object can be used as a key in key value pair dictionaries. That's worth stating. Any immutable object can be used as a key in a dict. And the best immutable object to do that with is a named dict, named tuple. Why? There's lots of reasons. The fact it's immutable, so it can be a key is one. Named arguments. Uniqueness. It works like unique constraint or primary key. Or compound primary key. It gives you a lot of SQL type things that are unexpected in the native library. Oh, thank you. Yeah, okay, I got a database and Mongo experience. Yeah, this is interesting because I avoid that next step, which is to back end this with Mongo or Redis, or there's a ton of ways that this can be back ended for persistence and all the various advantages that these different database systems give you. But I'm using the kind of lightweight in standard library way of doing it, so that I can back end it with other things later when it gets to be too much data for my local desktop or whatever. So there's so many candidates here now for keys and values, but the point is that the deepest part of the crawl is the part that would be nested most deep in your objects. So if you start there and think your way backwards, you can get the flattest object for making a long list of that will satisfy most of your needs. It's 80-20 rule here. There's deep discussions that could be had about degrees of normalization and such, and how many separate objects you break things into so that each object alone is as small as possible, and you avoid doing techniques which in Excel would be thought of as field stuffing. But I'm not going to go down those deep discussions. All I'm going to do is use my most common methodology here to figure out what shape I want. And really, a URL goes in and a crawl comes out. So the easiest possible thing here is at this parent level, no matter how deep you go into this, you can at least have a dictionary object where we call it crawls. Just use the plural of something that's in there because it's the deepest object and it's certainly the most voluminous. And so crawls can be equal to just a plain old standard dictionary, like that. And down here at the end, instead of losing all your crawls but your last one that has the single word crawl, which is accessible as we see down here, we just throw it all into a dictionary so that the thing that initiates the crawl function, right, here's the crawl function, crawl, this becomes, oh, this is what initiates, that's the input parameter, the URL becomes the key, right? So before the crawl data even exists, well, no, you do want it to exist. So it goes down here. You can do crawls with the key being the URL, and that's unique, right? So it makes a perfect key. It's just a plain old string at this point, but you're with a key of URL, you can contain, and it's an awful lot of talk for such a little bit of code, but this is my style. This is what you're going to be finding from me. The goal is to have as little code as possible and to have it as clear to read as possible. And I have at least two safety nets going on here now with persistence. First, it is that cashier library that is a decorator function around all my functions that do API calls, even if it's web scraping, so that it doesn't actually have to perform the web scrape a second time, and it hangs around for a whole week. But this is the second safety net, a dictionary which is in memory. You'll notice this takes no longer than it did before. Cashier is doing its job. However, when last time we only had access to a single crawl object, we now have crawls in memory, access, and this will take a while. This is not particularly Jupyter's strength in showing these enormous objects, but we have all the data from every crawl, and see how small this has gotten. So that just goes on forever, and that is the last time I'll be showing the raw contents of an entire crawl. But as you can see, this is like kind of the perfect setup for the no database step that's coming up clearly, because this doesn't belong in memory. The only reason I could look at it again or look at it now is because I am in a REPL environment and it's persisting in memory because it's kind of in a frozen state of running. It really takes a while to wrap your mind around, but I'll just do length of crawls to get some different output there that's still meaningful. 18 crawls, so that's 6 times 3, right? Backend Node, Express, Angular, Mongo with local Python management tool. Yeah, I don't know. That's definitely something I would talk about in a separate conversation. I don't know much about these larger frameworks, especially stuff that starts to bring Angular into the picture. This is a number of frameworks of a, I don't know, tech flavor that I haven't taken up. I tried to do Mongo, but the 3 servers was not my style. You had to be on cloud, at least during the days I did it. It probably changed a bit since then. But on the few times I have back-ended this, I've gone with Redis or Postgres for familiarity reasons, to either have whole SQL in the case of Postgres, or to have just the most NoSQL local single server kind of thing I could with Redis. SPHINX. Good, I've got people. Let's see. So, this is the big build that we're coming here towards. I've got enough data to certainly get it into a database. And now is the time we look at the Shelve API. Now, I've talked about Pickle from time to time, and Pickle is essentially single object persistence. Anything that you can have in memory in Python, you can serialize and dump to the hard drive. It's basically a way of saying freezing an object in memory on the hard drive to load it again. But there's this dumps and loads. It's just ridiculous, the language they used for it, even down to pickles, right? But pickles go on shelves, and shelves is a higher abstraction for object persistence that has slightly more natural language to it, excuse me, than does shelf. And it also has the added advantage that shelves are intended to be like a dictionary. So let me just read it, right? A shelf is a persistent dictionary-like object. So you have the dictionary API. When they say that, they're telling you you have the key value pair API. And this is what I've been saying. The difference with DBM databases, so DBM is a Unix database. It's the way of saying NoSQL without yielding to modern keyword buzz jargon. This is the database that's been in Unix since the 70s. There's nothing new about key value databases. Oh, the mean stack. Yeah, I've been looking at the mean stack. That's an alternative to, well, it's web development. So surprisingly, I can say very little about web development. Web dev is not my forte. I'm all back end. So tend to be all Python and keep my big library dependencies to pandas and requests. Well, good. Web dev people can definitely chime in and add to the conversation things that I can't. I was web dev once upon a time, but all my knowledge and stuff is hardly applicable anymore, except in a very old school way. The fact that I even hear words like Angular, Express Angular, which I associate with a JavaScript library for building front-end user interfaces, used in association with Mongo is a bit surprising to me. I hear a synthesis of two I see the connection. Mongo wants to live in the full stack world and provides an important piece, but I know nothing about these larger. I know nothing about the small building blocks of the full web stack, much less how they work together with other pieces. So I mean, Node is important. You can't get away from Node. It's like regular expressions or Python itself. It's the P in the pool of tech now, and knowing how to do a little JavaScript and knowing how to send that JavaScript to the Node engine is necessary, but that's kind of where my know-how begins and ends. I can write local code in JavaScript and say drop it into a scheduler, which is pure Linux. So I try and be technology agnostic in my back-end stuff, but I certainly don't know the front-end stuff. But back to where I was talking about. The difference with DBM databases or NoSQL databases is that the values in the shelf can essentially be arbitrary Python objects. So I could drop that entire clause, plural, into a single, item in the shelf, and into a single shelf in the shelf. But I don't think I'm going to. I think I'm going to make the key something higher and make each crawl a separate, so I can investigate based on the URL that was used as input. I should probably do it on the netlock of the URL that was used as input, because that URL is a potentially long thing, and it's just an entry point for the crawl of what came back in SERPs. I hope this is making sense to people, but this is the real SEO quality SEO Python content that I'm promising that I don't think other people are necessarily doing, and it's because it's part of my day-to-day work. This is stuff I would have to really think through anyway. And It takes maybe longer than it should when you're thinking out loud, but the code becomes better and long-term more maintainable because there's, you're not going to make stupid mistakes in front of a live crowd like this, and you're going to try and keep this code as small as possible. And the amount that this is doing with so little is quite spectacular. And this next step is something along those same lines because it's about to make all that crawl data persistent. We have two options to make it persistent. Wait till all the work is done and drop the resulting crawls object into the shelf, but because the individual crawl objects are going to be the data, the values we want to get out, and not the plural crawls object, it implies that the crawls object should be the shelf. Crawls plural stands for the shelves object, and by the time it gets to this point, it should be committed to the hard drive, and you should never have to think about doing something again later to get that particular crawl onto the drive because it has been written with its key onto the hard drive with the data of that iteration of the loop. Do you follow? Right? So what is the lightest touch way with this new library that we have at our disposal to do that? Well, anything that has to do with file writing to the drive is going to have a concept of opening and closing, as does this. And they even give a warning here. Do not rely on the shelf being closed automatically. Always call close explicitly when you don't need it anymore. And I hate that style of coding, as does everyone else on the Python platform, which is why it continues to say, or use shelf open as context manager. And all this indent stuff that people complain about with Python, oh, indents mean something, white space means something. This is one of those places where that is really your friend, because when you have the with keyword before anything that has an open method and gives it a file handle, that means when you leave that indented space it establishes underneath is an implied close, and it's a safe way of programming things with file open file objects. This is magic. This is pure magic right here. In fact, it's so magic, I will copy that and go exactly back to my Jupyter notebook, and to go exactly to that place where I say it should have been committed by that time, right? You're sitting on the data here. This object should be the shelf. So that means if I put the pattern in that we just saw in that exact location, I should be able to move my code around to sort of fit what's supposed to be here. Things should look similar, and in fact they do, right? Crawls is DB. URL is the key. And crawl is the data. I could have just copied and pasted that line up, but I think I get across the point. Now, the shelf itself with shelf open you got to know what shelf to open. That is the name of a file on the drive. If I read this correctly, when you've got a string literal next to an open, that's a file on a drive. That's not a key. So I do believe I should be able to say crawl data. And then all I have to do is import the shelf object. Yep, it's as easy as I thought. There's no fancy import. It's not like the URL lib. Wish URL lib was that simple. Import shelf. Why am I copying that even, right? Okay. It's always safe to re-import. while I'm breaking PEP 8 a little bit, I like my lines in increasing length so it always looks pretty. And according to PEP 8, you would rearrange these to be standard library first, custom stuff last. But I re-import it. I now have the shelf object. Now, amazingly and astoundingly, that should be it. Make a liar of me, of course, but I should do a before and after with looking at the drive to show the crawl.data file appear. I should be able to pop this out, right? Let's use Jupyter. Yeah, see, crawldata.dat. Oh, it provided its own extension. In fact, multiple extensions. Look at that. I certainly don't need the extra .data in there. So I'm going to fix that mistake right away. No wonder they didn't have an extension. They provide their own extensions on the shelf API. So this is really using Pickle, and it's database stuff for sure. For all I know, the Unix DBM program is back-ending this, or in a Windows equivalent. It's very Python-like to have standard tools that are operating system provided. This happens with XML. LXML is often an optimized C component of the operating system, and it causes problems, but it's the people who make the tooling who deal with that, how to back end these things. But I trust it's going to be a nice key value database that's lurking in either the Python install or something OS supplied. So I got rid of that. Now it's all in memory. So at this point, what you really want to do is kernel restart and clear all outputs, right? Because with all this caching and persistence stuff we're doing, there's safety nets all over the place. You're not going to be abusive to any outside services you're hitting. And look how little code that is to do so much. I'm so pumped about this because even though I'm not showing you my exact use case for all this stuff, and where is that kernel restart? Restart and clear. Oh, okay. I was just impatient. I can show you the general case, and then the use case is what I just go and do on my own. But this general tooling is exactly what I've always been advocating and talking about over the years. Okay, so I've cleared the output. Now I want to delete those files. I guess I should try and do that. All that stuff here. Oh, I have crawl that's used for the pickle, and fortunately, it creates no collision. Probably a bad matter of style. This is not the fastest way to do it. I am tempted. And again, the benefits, when I talk about Linux, Python, Vim, and Git, the benefits, and I should do this before I delete that last file, of having WSL as a first-class citizen. Well, the drawing, I don't think I'll be doing that much right now. I may, but I'm going to move that there. And on this window, bring up another terminal. Whoops, I did the wrong keyboard shortcut. Oh, good, W is gone right now. I had Twitch here for live streaming. I've since switched to OBS. So my Control W did not trigger the wrong thing, but with one CD surveyor, I can do an LS, and even though this is my Ubuntu system, there is that data right there. And instead of finishing with that delete I'm about to do, I'll do this one delete from over here so you can just really appreciate what this sort of integration, blurring the lines between Linux and Windows host operating system really buys you. Should probably do it on its own, but I do force a refresh there. So the kernel has been cleared and reset. So we can just step through these things again. Something in here takes a little bit of time, although not untypical on the first run after a kernel reset for the first cell to take a little bit longer. Things are being fired up. And so how is this different from anything from before? Well, First of all, I can now access all that data. It is in memory as the plural crawls, but it also should be able to be pulled off of the drive again as a completely different file name using something very similar to this, because you can essentially reverse this process. Okay, so reversing this process will give some insight as to what this process really is here, because in a typical Python fashion, profound awesomeness is being concealed in extremely simple API. So I'm not going to go through the whole file opening closing that is implied here, but what I will do is change the name of things that are being used. So opening it as DB is exactly what it should be, but now we're going to say as DB. Oh, wait, that was incomplete. People who are following this are probably going, "You fool, there's a disconnect." And it took until I copied it out to understand the disconnect. You can't do something like this without using the file handle. That file handle is the file handle. That's what controls that connectivity there. So that original one should be crawls, so that by the time crawls comes out of this, crawls only existence now is as the dictionary, the shelf dictionary object. So I've got refactoring there. That's some refactoring, right? That took a long time. And how about that? There's some refactoring too. So we do have to re-execute that, but it will be seamless. However, this is a perfect example of where restarting the kernel tells you things that you would otherwise get tripped up on. Because if I were to look at a variable named crawls, I don't want to show the whole thing because it's enormous, but it will be there. It's in scope. And kernel, restart kernel, restart. And I don't think it should. I don't think it should be in scope. I think that when you use that with open, in the first place a name such as that occurs is as a file handle to a real physical thing on the hard drive, that an attempt to re-access that after a implied close should fail, right? So we go boom, 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 boom. This is after a kernel restart, mind you, right? So, hey, see, crawl's not defined. Now, where is that? As crawl. Okay, so I need to double check the API. People are probably shouting at me, you're missing something. And I am indeed. This is where you look at the API, and it's not it's clearly not. I mean, I know what my error is. It's not the file handle. Oh, as crawls. Singular and plural. That easy? Yeah, that easy. Okay, so after the last close, which is implied here, crawls in plural form should not actually be there. Length of crawls, that should fail. Right, exactly. It's not there. So this is where the reversing this comes into play. I'm not going to use the word crawls. I am going to use some local file name. No, locals, I'm getting my terminology. But it's going to be, foo. It doesn't matter. That has just loaded the crawl data out of memory, or off of the hard drive and into memory. So foo is now what crawls plural was once before, I believe. Let's take a look at the length of that. It should be what? 6 times 3. No, so it's not. Look at that. So what I'm putting into here, this is the flatness that I'm doing in the loop. A URL goes in, a crawl comes out. So it's not the the number of sites that I looked at to crawl, but it's the number of pages that have been crawled, despite what my starting keyword was. This is the flatness that I was discussing. And so it's easier to look at than the full crawls data because it is, let's see, let me make sure that my logic is good here. We execute a crawl. We create a file handle called crawls. The data on the hard drive will be called crawl. And then the file handle with the key of the URL that it has just used to create that crawl data. So there should be keys inside of, there should be URL keys in a dictionary-like object. So when we open it down here, we should be sitting on top of a dictionary type object with using URLs as keys. Let's see if that's the case. So first type foo. Oh, I created a set. And that is kind of like what I was looking at. Let's take a look at foo again. Aha, we don't need to feed URLs in. That's the key. That is the one that was hanging around from the last iteration of the loop. So it's not as clean of a reversal of this as I thought. As things go in, it gets put in with URLs as key, because of the way the main function, or not the main function, but the outermost, the root, the home, the global space works in Python. When you have a loop and a variable is used for the first time inside a loop, and you can change this with myint. The people are going to say, oh, shortcoming of Python, but don't sweat it. You just got to be aware of it. If you're not using explicit variable typing with myint, then you've got to be aware of these things about things like leakage of things, so that because it's leaking, I thought it was something that I used there to reverse that process, but it's not. I'm just allowing foo to escape the closing. So this can escape it, but something else can. Let's see. I can't even look at length of foo. Invalid. Oh, closed on shelf, right? Okay. Pointers. So when you set something equal to something else, if this is a high-level abstract object, anything other than, say, like an integer or some low-level data type, if it's a mutable data type, then this is a reference to that mutable data type. However, there are variable ways to handle that. Probably the formal way is that. Didn't like it. This is why Python is not fully object-oriented, because not everything has the same, like there's no dot length like there is in other languages and stuff. But any type of object like this is going to have an API that is probably addressable using index slicers. And this is the same as the notation from the beginning of the object to the end of the object. Let's try that. Nope, didn't like that. Can't slice crawls. So crawls is a dictionary-like object while it exists in memory here. However, I want it to, oh, well, you know what? One answer to that is to just stay inside the with. Why am I trying to escape? Lean into the strengths of what you're doing. So you have file handle crawls. So for key, which is actually URL, in crawls, print URL. And so this will at least let us see, yeah, why force it to escape out of that? Use the data while you have it. Interesting lesson. I can get rid of some of these things now. But that is proof. I am reopening the data from the drive. In fact, the real proof here and I guess the end of the video, because having done this has now achieved that purpose of that video that I sort of stated, which is a node database, doing database things in Python with very, very lightweight API calls to things in the standard library, like the shelf library, that can be back-ended later with other things because of the way this works in Python. Anything can be connected to anything, and you can swap out what back-ends shelf and replace the DBM type style database. It might even be using SQLite for all I know, because row and column databases like SQL and SQLite, Postgres, all these things can be tricked out to be key value databases. It's just a matter of how stuff is set up in the back end. So I'm doing back end work. There's back end work to the back end work. The people who make the tools have made a lot of decisions so that when I settle down to doing work like this, it is as easy as possible, and the code can be this small and pleasant to look at. But what I'm going to do right now is I'm going to create a brand new notebook. So if I have my launcher, there's no launcher. It's really interesting. So there's no way to create new notebook here that I know of. New folder, paste. None of these is new notebook, but there is new launcher. Once you have new launcher, you can create new notebook, which will be in the same location as your other ones. You see it's in that same directory. I already had an untitled there, which is actually loaded. I should have probably used that. But having a brand new one will help me make my point. Import shelf, S-H-E-L-V-E, right? Okay. And with open, right? With, shelf.open, because open is a method of shelf. We put in that same word. I used crawl as, and we give it a file handle. Crawls is the file handle because it's multiple crawls. Colon, because it's a looping type object. Is video frozen? Let me take a look. I have been streaming for a while. This may be my longest stream. This says I'm still streaming. Let's see what YouTube says. Can I see myself move? I think I saw some jumping on the screen. Wow, 1 hour, 7 minutes. Video may be frozen. Oh, I saw something jump on the screen. Maybe I just have to let it catch up. I'm so close to the end. I think I'll finish up now, and then we'll move on to something else later. But the end of this concept really is the fact that we now have for URL in crawls print URL, because URL is key. And there, the URLs come right back out. And inside of there, if I really wanted to, I could, use the URL as a key, and I'll just break out after one loop. I can print just to show you that the full crawl data is in there, where crawls, for URL and crawls, we can actually use crawls just like a dictionary with the URL as the key. And because that's so much data, I will break out of the loop after just the first one, and set empty. But that's my site, that's my slideshow site that didn't have URLs to crawl. I couldn't crawl from there. It's ironic, it's funny that that's the first one. So We'll do it on the second one for I, comma, URL. Well, for a dictionary-like object, you shouldn't even need to do for URL and crawls, except you do need a URL value. But you can use crawls. It's probably numerical indexes, right? So I should be able to print crawls, the first object, and not have the loop. You don't need loops for this sort of stuff. If it's something that you can iterate through and it is not a generator, I mean, there are types of iterable objects that you can't use numeric keys on because you have to go through in the order they're discovered. I don't think this is one of them. Int has no object in code. This is the way I'm using the key, right? So yeah, there's no URL. So I mean, I'm doing that wrong. I just look for a numeric index there too, item, but they're keys, so yeah, it might not be an object I can address directly. File. It's a dictionary object. I can't use that, so you do need to tweak out the URL values. But the URL values are the ones that we saw, so I could paste in a one of those literals from what we saw output here. Let's leave this one here. Just in fact, I'll get it to the break as well. What did I? No. You know what? This is fine. So that'll show me my URLs. And now we can take one of those, like my own site, and instead of the loop, say crawls, and feed an actual URL in there and print that, so you can see that the full crawl data of the site is actually available. And we have loaded it here off of the drive in just, you know, these 3 lines of code. Don't need that anymore because we have that value we were looking for. So it's database, right? I mean, that's database as it gets. Well, not as database as it gets. We're avoiding as database as it gets. We are trying to stay in a pure key value world without having to think about much else other than it does have to end up on a hard drive. So this, with shelf open is the big concession to local persistence and database-like behavior, where you're just trusting